Watch the number on this screen for a second before you decide it's a typo. 106 miles per gallon. Guinness World Records didn't take a press release's word for it either. They sent independent adjudicators to a closed test track, watched every run in person, and stamped it official. This isn't a concept vehicle hidden behind velvet rope at some auto show fantasy display. This is a production car, built on a real assembly line that you could drive from New York to Chicago and watch the fuel gauge barely flinch. And the company that built it isn't Toyota, isn't Honda, isn't Ford, isn't General Motors. It's a Chinese automaker most Americans have never once heard of called Geely. By the end of this video, you will not forget that name again. Here's why this story deserves 10 minutes of your attention instead of 30 seconds of scrolling past it. The man who built this company started with $3,000 in a factory that made refrigerator parts. The engine itself just cracked an efficiency threshold Formula One teams have spent billions chasing and still haven't matched. And this exact technology is already being engineered into cars, sold under brand names you already trust in your own driveway. If stories like this are the reason you're here, the like button and subscribe are how you make sure you don't miss the next one, because we cover the shifts most people don't notice until the ground has already moved under them. Let's start where this entire story actually begins, in a farming village most of the world has never heard of. In 1963, in a small farming village in Zhejiang province, a boy named Li Shufu was born to a family with no connection whatsoever to cars, engines, or industry of any kind. In 1986, at 23 years old, he borrowed roughly $3,000 from relatives, a sum that wouldn't cover a used sedan today, and opened a tiny workshop making replacement parts for refrigerators. Nothing glamorous, nothing that hinted at what was coming, just a young man who refused to stop building things with his hands. By 1994, he'd moved into motorcycle manufacturing, and then, in 1997, he said the sentence that made grown men in the industry laugh out loud in meetings. He was going to build cars. He had no engineering background, no factory equipped for automotive production, no connections inside an industry that, at the time, barely allowed private companies to exist in China at all. When journalists pushed him on how difficult building a car actually was, he reportedly shrugged it off with something close to, "A car is just 4 wheels and 2 sofas bolted together." People didn't just doubt him, they dismissed him outright. But in 2001, Geely became the very first privately owned Chinese company ever granted a license to manufacture automobiles, a genuine historic first, and Li Shufu was only getting started. In 2007, he wrote directly to Ford Motor Company offering to buy Volvo, and Ford didn't even bother responding. He flew to the Detroit Auto Show in 2008, and asked again in person, Ford brushed him off a second time. He came back once more in 2009, better prepared and more determined than before, and in 2010, the farmer's son from Zhejiang walked out of Ford's own headquarters, having purchased Volvo outright for $1.8 billion cash, a sum roughly equivalent to buying 900 fully loaded Boeing 737s. Except what he bought was an entire Swedish automotive institution with nearly a century of engineering prestige behind it. The industry didn't just take notice, it went quiet, and he still wasn't finished. In 2018, he acquired nearly 10% of Daimler, the parent company of Mercedes-Benz, instantly making him the single largest individual shareholder in one of the most storied luxury brands on the planet. Sit with that for a second. The kid mocked for thinking he could build a car became the biggest individual owner of Mercedes-Benz stock. Today, Geely Group's portfolio spans Volvo, Polestar, Lotus, Lynk & Co., and several other global brands. And that same relentless, obsessive engineering ambition is the exact force that produced the engine we're about to break down. But to actually understand why this engine matters, you have to first understand the problem the entire auto industry assumed only one technology could solve. Electric vehicles were supposed to be the clean, obvious answer to everything, and in fairness, plenty of that promise is real. But living with one day to day has proven messier than the advertisements ever let on, and the cracks have been visible for a while now to anyone actually driving one. Start with charging. The commercials show you pulling up and plugging in like it's nothing, but even at today's fastest public stations, getting back to 80% charge realistically eats 20 to 40 minutes. That's not a quick fuel stop. That's long enough to eat a full meal and watch half a sitcom episode, and it turns from a minor inconvenience on a solo drive into a genuine flashpoint with restless kids in the back seat and a schedule slipping away. Then there's cold weather, which almost never makes it into the brochure. Electric batteries are genuinely sensitive to freezing temperatures, and once it drops below 32 degrees, most EVs lose somewhere between 30 and 40% of their advertised range, meaning the 300-mile range you paid $60,000 for quietly becomes 180 miles on a January morning in Minnesota, and that math doesn't bend in your favor. Battery replacement is the number nobody wants to say out loud. These batteries degrade over years exactly like the one in your phone, and when they eventually need replacing, the bill can run anywhere from $10,000 to $20,000, roughly the price of an entire second car. wiping out years of accumulated fuel savings in one single invoice. And then there's the part of the conversation that usually gets left out entirely. EV batteries require lithium, cobalt, and nickel, and extracting those materials involves massive open-pit mining operations, and, in the case of cobalt specifically, well-documented human rights concerns in the regions where much of it is sourced. This isn't a fringe talking point. It's an ongoing industry reckoning. Stack all of that on top of a national electrical grid that the U.S. Department of Energy has repeatedly warned was never designed to handle tens of millions of vehicles charging simultaneously, and you get a genuinely uncomfortable picture. None of this means electric vehicles are a failure. They absolutely have a real future ahead of them. But for hundreds of millions of drivers right now, today, an EV isn't a seamless upgrade. It's a lifestyle renovation. So the real question became obvious. What if, instead of asking everyone to rebuild their entire routine around charging, someone simply figured out how to squeeze so much efficiency out of a traditional engine that most of those old trade-offs stopped mattering? That is precisely the question Geely set out to answer, and the answer stunned people who'd spent entire careers assuming combustion engines had already hit their ceiling. In April 2026, on stage at the Beijing Auto Show, Geely unveiled what they call the IHAV Intelligent Hybrid System, built around a new engine called the BHE15, a modest 1.5-liter four-cylinder, roughly the same displacement you'd find under the hood of an entry-level economy hatchback, nothing that reads as extraordinary on a spec sheet. But the number Geely put on the screen next stopped the room. 41% thermal efficiency. Translate that into plain terms for a second because it matters. Every combustion engine wastes energy. When fuel ignites inside a cylinder, only a portion of that released energy actually becomes forward motion. The rest bleeds away as heat through the exhaust and engine block. Thermal efficiency is simply the percentage that survives that process and becomes usable movement. A typical engine on American roads today converts somewhere between 30 and 35% of its fuel into motion, meaning 2/3 of every gallon you buy is quite literally burned off as waste heat into the air. Toyota's hybrid system, the benchmark that's defined efficient for 3 decades running, tops out around 41%, and that number has stood essentially unchallenged as the ceiling. Geely just hit 48.41%, independently certified by Guinness, now sitting in the record books as the highest thermal efficiency ever measured in a mass-produced engine. Full stop. Here's the comparison that actually makes this land. Formula One engines, the most obsessively engineered combustion machines humans have ever built, the ones teams spend hundreds of millions of dollars refining by fractions of a percent, operate around 50% thermal efficiency. Geely just put a production engine that goes into a car regular families can buy within 2 percentage points of Formula One performance. That's not an incremental improvement. That's an entirely different category of achievement. But a number on a dynamometer only tells half the story. What happens once that engine is bolted into an actual car and driven on an actual road is where this gets even harder to believe. Geely paired the BHE15 with a 308 horsepower electric motor and an AI-driven energy management system that continuously reads driving conditions in real time and decides, moment to moment, whether the engine, the motor, or both, together should carry the load. They took the resulting car, the Geely Galaxy M8 Grand Sedan, to a closed test circuit in Hainan province and ran it through a standardized efficiency evaluation. The result, 2.22 liters consumed per 100 kilometers, which translates to 106 miles per gallon in American terms, independently verified by Guinness as a second, entirely separate world record from the engine efficiency milestone, 2 verified records from one car program. Now here's the number that actually makes this real for your own driving life. A typical car with a 15-gallon tank averaging 30 miles per gallon gets you roughly 450 miles before you need to refuel. That same 15-gallon tank at 106 miles per gallon delivers close to 1,600 miles. That's driving from Los Angeles to Denver and most of the way back on a single fill-up. And the comparison that really seals it is Toyota's own showcase. In 2024, Toyota drove a Prius from Los Angeles to New York specifically to demonstrate best-case hybrid efficiency, a carefully planned, heavily promoted run that averaged 92.9 miles per gallon and got celebrated across automotive media as a genuine milestone. Geely beat that number by more than 12%, not with a hand-built prototype or a specially tuned show car. With an ordinary production sedan a customer can walk into a dealership and buy. To be fair, a closed circuit in Hainan isn't the same as stop-and-go city traffic in the snow. Real-world mixed driving will almost certainly land below that peak number, the same way it does for every efficiency claim in the industry. But even discounted for that reality, the gap over the previous benchmark is enormous. Geely's own spokesperson, Victor Yang, stood in front of cameras and said their technology will comprehensively surpass Japanese hybrid engineering, a direct shot at Toyota and Honda, the two brands that have owned the hybrid conversation for 30 straight years. And when you actually line up 48.41% against Toyota's 41 and 106 miles per gallon against Toyota's own 92.9, that statement stops sounding like bravado and starts sounding like simple arithmetic. What makes this even bigger, though, is that Geely isn't out here alone. While most Western headlines have stayed locked on the electric vehicle race, an entirely separate and much larger hybrid arms race has been quietly accelerating across China, and most of the auto world hasn't clocked it yet. BYD, the company that recently overtook Tesla as the planet's top-selling EV manufacturer, released its fifth-generation hybrid system back in 2024 at 46.06% thermal efficiency, just behind Geely's new record but still far beyond anything Toyota or Honda currently produce, and BYD's hybrid lineup can already travel a combined 2,100 kilometers, over 1,300 miles on one full tank plus one full charge, roughly the distance from Miami to Boston without stopping once for either fuel or electricity. Leapmotor, a brand most Americans have genuinely never encountered, hit 45% thermal efficiency in its L7 sedan. Chang'an, Chery, GAC, and Great Wall have all shipped vehicles with combined ranges past 2,000 kilometers within the last 18 months alone. And none of these are concept cars waiting on a future release date. They're sitting on dealership lots right now. Meanwhile, Toyota and Honda's flagship hybrid systems remain parked at 41%, and Ford, General Motors, and Stellantis are still mostly running engines that haven't cracked 35. The distance between 35% and 48% isn't a minor competitive edge, it's a generational leap. The same category jump as tube televisions, giving way to flat screens almost overnight. The underlying technology hasn't improved incrementally. It's moved to an entirely different tier. And here's exactly why this stops being a China-only story and starts affecting what's parked in your own driveway. Geely doesn't only sell cars under the Geely name. Geely owns Volvo outright. Geely owns Polestar. Geely owns Lotus. Geely runs a joint venture with Mercedes-Benz building smart cars. And through a powertrain partnership called Horse Powertrain, Geely actively licenses this exact engine technology out to other global manufacturers. Which means the BHE-15 engine and the IHIV system are not staying inside Chinese borders. This technology is already slotted into Volvo's upcoming product roadmap. It will appear in European showrooms within a few short years, and it will eventually land in American dealerships wearing badges you already recognize and trust, without most buyers ever realizing where the underlying engineering actually originated. Engineering decisions being finalized in Hangzhou right now are going to determine what sits under the hood of cars sold in Los Angeles, Chicago, and New York before this decade closes out, and the ripple effects go well past a number on a window sticker. A hybrid delivering 106 miles per gallon means filling your tank roughly once a month instead of once a week. It means road trips without the low-grade anxiety of hunting for a working charger in a rural stretch of highway. It means no rewiring your garage, no reworking your morning routine, no budgeting years in advance for a potential $10,000 battery replacement for drivers in cold climates, small towns, or anywhere the charging network still hasn't caught up. This isn't a consolation prize. For a huge number of people, it's genuinely the more practical answer for at least the next decade. While the grid and the charging infrastructure slowly catch up to the marketing promises, it's also a real environmental story in its own right. Dramatically less fuel burned means dramatically fewer emissions, without the same mining footprint that comes attached to a large EV battery pack, different path, same direction, real progress either way. And for the industry itself, this is a genuine reckoning. Detroit and Tokyo both built their long-term strategies on the assumption that hybrids were a temporary bridge on the road to a fully electric future. What Geely just proved is that the bridge is far longer, far more capable, and far more competitive than anyone in those boardrooms had actually planned for. So here's the fast version. A boy from a farming village borrows $3,000 to fix refrigerators, gets laughed out of rooms for wanting to build cars, buys Volvo from Ford anyway, becomes the largest individual shareholder in Mercedes-Benz, and 3 decades later his company produces the most fuel-efficient production engine in recorded history, one that sits within 2 points of Formula One performance and gets independently verified at 106 miles per gallon in a car that costs a fraction of what a comparable EV does. Zoom out. And this was never really a story about one clever engine. It's a story about what happens when an entire country stops treating combustion as a dead-end technology and instead treats it as an unsolved engineering problem still worth billions of dollars of obsessive refinement, while the rest of the world quietly assumed the book was already closed. The future of driving wasn't decided in Detroit, and it wasn't decided in Tokyo. It was decided in Hangzhou. And now every major automaker on the planet has to figure out how to respond, whether they're ready to or not. If this opened your eyes to something you hadn't heard before today, the like button and subscribe. Make sure you don't miss what's coming next, and turn on notifications too, because the next story out of China makes this engine look almost modest by comparison. Now I actually want to hear from you. If a hybrid genuinely delivered 106 miles per gallon at a fraction of an EV's price, would that change your mind about going fully electric, or are you still all in on batteries? Drop your answer in the comments below. I read every single one.